All right, this is section 7.3, the law of cosines. And so we talked in the previous section that that there's four different possible combinations of information that we can that will help us solve an oblique triangle. Remember, an oblique means doesn't have a right angle. All right, so if there's two angles on any side, which would be the ASA or SAA situation, or two sides and an angle opposite one of them, that was handled by the law of sines. Three sides, if we have that information, or two sides and the angle between them, which would be SAS, right? This is SSS. This would be SAS. Notice the difference, right? SAS different from SSA, right? SSA means that you have a triangle and that you know the information that you have the following measurements, right? SSA means you have a side, and an angle. SAS means you have a side, an angle, and then the other side. Notice the angle is between the two sides, whereas for SSA, the angle is not between the two sides. It's one of the other angles. All right. And then SSAS means you have the three sides, right? And for those to finish solving, right, to find the missing information, you use the law of cosines. Okay, so the law of cosines is written there. That means you can write it whichever way you need to solve, depending on what you need, right? All right, so and usually, for example, if you have B and C, but you're missing A, but you have angle A, then you would use this one. If you have A and C, but you're missing side B, side B, or if you're missing angle B, then you would use this one. And if you have sides A and B and you're missing side C, or you're missing angle C, then you would use this one. Same thing on top. If you're missing side A or angle A, you would use that one right there. Okay, so notice that tells you which one to use, right? If I'm missing side A or angle A, missing side B or angle B, missing side C or angle C. All right, so a proof can be done in the following way. So you would draw a triangle, right, and overlay it on the coordinate plane, where this is 0, 0, that vertex right there. Yeah, and so that would be y and x. Yeah, there's your x-axis and your y-axis. So the x-axis runs along the base of the triangle. So this point over here, you notice this length is c, so that point has coordinates c, comma 0. And then point C up here has coordinates xy. Okay, so this has coordinates xy. Okay, now if you look at what x should be, well, you have this length right here, right? That's x, and that height right there is y. Yeah, so you have the cosine of A, right? The cosine of A is x over b, right? Or if you solve for x, you get x equals b cosine A. So these coordinates can be written a different way, right? So x is b cosine A. And then you also have that sine of alpha is opposite, right? Which is y. This is y, right? We called it h before, but now we can call it y. Over b, so y equals b sine A. So these coordinates xy can be written b cosine A or b comma b sine A. Okay, all right, and then we're just going to find this distance, that distance right there. So we know that the distance A is the square root of, and I'm just going to use the distance formula. So it's the square root of the differences in x, so it's b cosine A minus c squared, plus the differences in y, b sine A minus 0 squared. Notice that's just going to be b sine A just b sine A squared, or b squared sine A. Okay, and I'm going to square both sides. So this will be a squared equals, and then I'm going to square each of these. Notice the radical you get rid of it by squaring both sides, but then you still have to square these. So b cosine A minus c squared is b squared cosine squared A minus 2 CB or BC cosine A, and you can distribute if you're not sure how to get that. plus c squared. So you can just distribute b cosine a minus c times b cosine a minus c. Okay, I'm using a little formula that I know. But you don't have to. You can just distribute. Plus b squared sine squared a. Notice I'm just squaring that, right? B squared sine squared a. Okay, so you have a squared equals, and I'm going to put these next to each other just so we can see them. I'm going to factor out the b squared also. So b squared times cosine squared a plus sine squared a. Right, that's those two right there. Right, and then the other two is plus c squared. That's that one. And then minus 2 bc cosine a. Okay, so I put those two together, these two over here, factored out the b squared, and then the plus c squared, that one, and then the minus 2ab cosine a, minus 2 bc cosine a. All right, so cosine squared a plus sine squared a is just 1, so this is a squared equals b squared plus c squared minus 2 bc cosine a, and that's what that says up there. Okay, and if you wanted to complete the proof, you would just rotate, right? So it would look something like this, just to get you started. You would rotate, so this would be b over here, c, and a would be somewhere up here, right? And you would do the same thing. This is c, this is a, and this is b. Right, so this would be A0, this would be XY over here, yeah, but then you would do the same thing. You would say, let me see, so X, the cosine of B is X over C, right, so cosine B is X over C, so X equals C cosine B. Okay, and sine of B is y over c, so y equals c sine b. Okay, so these coordinates could be written c cosine b, comma c sine b. And then you do the same thing, you find the distance b. So you'd say b squared, b equals the square root of c cosine b minus a squared plus c sine b minus 0 squared, and then just go through the same process, and you'd find one of the other ones, which would actually be this one, and then you rotate again and you can do the other one. Okay, all right, so to solve an oblique triangle given SAS, one, we find the length of the side opposite the known angle, so we'd find the third side using the law of cosines. Notice, because we'd be missing the side across from A, I'm sorry, whatever that one is. Okay, so we'd find it. And then use the law of sines to find the measure of the angle opposite the shorter of the two given sides. And this angle has to be acute, because remember, the shorter is opposite the smaller angle and the longer is opposite the biggest angle. So if you're not looking at the biggest angle, the other angle has to be acute. All right, and then find the measure of the third angle by subtracting the sum of the measures from 180. All righty, so let's try one. And maybe we'll just set it up, and then we'll finish it in class. So triangle ABC with angle B, and I'm going to just draw a generic triangle. So A, B, C. Angle B is 61 degrees. C is 19, so this is C. And, all right, C equals 19. A equals 28. And so we're missing side B. Okay, so this first tells us that we use the law of cosine to find side B, right? So we're going to write B squared equals A squared plus C squared minus 2AC cosine of B. Yeah, and when I punch that in, I get B squared equals 28 squared plus 19 squared minus 2 times 28 times 19 times the cosine of 61 degrees. And notice I can figure that out pretty fast. Okay, let's start number 2 here. Part 2, solving triangle if you know the three sides. All right, so how do we start that off? We use the law of cosines to find the largest angle opposite the longest side. Notice that takes care of, if there is an obtuse angle, we'll find it first, and then the other two have to be acute. Okay? Or we already found the biggest angle if they're all acute. Alrighty, so let's draw a generic triangle here. So we have A, B, C, and A, and side B and side C. And side A is 62, and side B is 48, and side C is 41. So the biggest side is 62, the biggest angle is A, right? So I'm going to say A squared equals B squared plus C squared minus 2BC cosine of A. And notice I don't know what A is, so I won't have cosine A, but I'll have all the other parts. So I'll have 62 squared equals 48 squared plus 41 squared minus 2 times 48 times 41 times cosine of A. And so because cosine A is all that's missing, then I'll be able to solve for it. And I'll use the cosine inverse to find A. All right, and we'll finish that in class. And I think we'll finish the last one in class. The last one is about a ship. We'll leave that one for class. Okay? So this will be the end of the video for section 7.3.